Hi everyone. We recall that strings and lists, and for that matter, another data type which we haven't mentioned yet, the tuple, those data structures are able to resolve each individual element or object within the structure to an actual subscript or index based on the order or sequence of where the object is in the data structure. And we then talked about how sets weren't able to do that because there is no tracking or recording of the objects. Thus, maybe the set is more flexible, it takes up less memory, less processing power. The drawback is that it cannot have duplicates and there is no ordering because it doesn't have a system of ordering. What if I told you there is another data structure out there that is like a set, however, it is able to resolve to other pieces of data. So it acts like a pair. So you might have a piece of data X and it links or it resolves itself not to an index, but to an actual other piece of data. We call that in computer programming or computer science, we call that a key value pair. Let's take a look. All right, so let's focus on this area of the screen, the circle with the plum color, I guess. I'm sorry. I'm just going by the colors that Microsoft Word has used in its drawing tool. So this represents a set. Each item is unique. We have a blue square, green square, and so these represent the various objects which would be in a set. And you recall a set is kind of like a grocery bag. However, in this key value pair data type, the set is linked to a value. So this you can almost say this is key 1 or a blue key that's a green key and whatnot. So this blue object or this blue key is linked to this value here, V1, and this key is linked to this value, and this is linked to this value. So in other words, this entire, and let me grab my drawing tool, and I'll grab a highlight, or you know what, I'll just grab this. So in other words, this represents the entire object right here. So you can almost say there's 3 objects, but it's not just the key, it's the link from the key all the way to the value here, and it's the link to the value here. So here's an actual human example right here. So we have Mr. Frank Summers as a string, and this person or this object is linked to, in this case, the number 45. We have Jay Gatsby, one of the main characters in The Great Gatsby. Actually, the main character in The Great Gatsby wasn't Jay Gatsby. It was the guy that would become his best friend. And anyways, Jay Gatsby is linked. I just linked it to this random phrase alpha. Now, interestingly, here is another data type which I haven't even mentioned yet. This is what we call a tuple. And essentially a tuple or tuple, however way you want to say it, a tuple is like a list. As you can see, it's a sequence of more than one type of data, but the main difference between a tuple and a list is it is immutable, like a string. So a list is mutable, a tuple is immutable. And for this reason, and I just wanted to say, as you can see, if you took a look at this data type, this is a string, that's a string, and you notice that it's linked to other things. So the keys have to be, they can be any object, so this as long as the object is immutable. So a string is immutable, as you can see. So this is immutable, and this tuple is also immutable. That being said, it's linked to other pieces or types of data that don't have to be immutable. Anyways, I'm hoping you understand that this tuple and this string and this string, these are the keys and these are the values. All right, let's start off with talking about tuples or tuples. We start off with a basic tuple right here, and we know it's a tuple because it begins begins and ends not with a bracket or curly brace, but it ends and begins with a parentheses. That is the signature syntax for tuples or tuples. And guess what? It is a lot like a list. We can have, in general, it's a linear sequence like a list, and we can have various items within the same tuple. So we can have even like a double type or float type, 45.14 or something like that. And we can, now it does support sequencing or subscripts. So the second position, which would be hello world, or excuse me, I'm sorry, because I missed the 14. I was taking 3414 as the same value, but it's actually 0, 14, and foobar. So if we wanted hello world, that would be the third position. Now we can say my tuple multiplied by 4, and we get the same tuple within the same structure multiplied by 4 times. So it does allow us to index, unlike sets, because it does imply that it tracks the order. But here's one thing we can't do. Unlike lists, we can't say, for example, my tuple third position, which is hello world. Let's go ahead and try to change it to just another number. Let's say the number 2, and we can't do that. However, if we said my tuple equals list of my tuple like this, and if we could just if we could print it out like this, and we said my tuple index or offset number 3, which is hello world, is, well, let me just print it out and just say hello world. But we can't say, for example, it is equal to the number 2. We can, because it's a list, but we couldn't do that if in fact it was a tuple. But because it's a list, we have successfully changed hello world to 2. However, we couldn't do that if it was a tuple, because it doesn't support item assignment. Okay, as it says in Python, a key value map or a key value pair is what they refer to as a dictionary. Now, in other languages, key value pairings are referred to something else, but since this is a Python class, we're going to refer to it as Python refers it. It refers it as a dictionary. So here we have we'll call it word, and here's the definition of the word. So I created this little dictionary, book to main character, just to shorten it up. I said B2MC, and for example, the book called Salem's Lot. All of you heard of that book by Stephen King. It was a TV series, miniseries, and everything else. The main character is a meek and humble writer in Massachusetts, or Maine. You know, how can I forget? I've read the book so many times. In Maine, Jerusalem's Lot, Maine. His name is Ben Mears. Bram Stoker's Dracula. I believe the main character is Jonathan Harker. He plays a what they call a solicitor, which is actually in America they call that an attorney. Anyways, so you can imagine in the drawing before, you have the set of books, and it is linked to the value. In this case, it's this and this. Now you can have as an infinite amount of pairings as you want, just to keep things simple. I only added 2. I'll press enter. Now the key is you can easily add entries into this. So for example, you could say B2, and how you do that is you first identify the new key, and you could say another book is, we'll just say the book ABC, and we'll end this, and that is equal to 34. And if we go ahead and we want to print out B2MC, we can see that it has added that. Interestingly enough, it supports the dynamic changing of the value. So we can say something like ABC is plus equal to 10, and we can go back to this, and we can now see that ABC is now 44. And imagine, if you will, something like bowling scores or something like that. You can potentially give somebody a bonus afterwards.